Continuing with this idea of definite integrals and area representation, I want to show you some that are on Delta Math and talk a little bit about how the location of the area actually impacts what we know about the sign of the answer. When I say sign, I mean positive or negative, not trig. So when I have something like the picture that you see here, and we have all these different areas that are bounded, we have area A, B, C, D, and E. If you have an area that is located below the x-axis, you'll actually get a definite integral that is negative. The negative, obviously, area can't be negative. You can't have a negative area in terms of some sort of real life context. But the negative, what it's doing here is it's giving you an idea of the location of that area. And then any area that is above the x-axis is positive. Again, that positive it's basically giving you an indication of where it's located. So it is actually possible to have a definite integral where you have areas that are accumulated and you can actually get 0 as your answer, because if you have the same amount of area above the x-axis as you do below the x-axis, that will create like a canceling effect and give you 0. So here's what they're going to ask you to do on Delta Math. And most of these are pretty quick. And I think it's going to help me here to have some colors to kind of show you what's going on. So they're going to give you this region, and you'll notice there's nothing geometric about these regions. They're not triangles, they're not semicircles, they're very obscure, abstract shapes. So they have to tell you the area of each of them. So they're telling you that the area of region A is 8 units. They're telling you that the area of region B is 4. The area of region C is 7. D is 15. And E, just trying to color code things here. Ooh. E is 20. And it wants to know what is the value of the definite integral that goes from -4 to +3. So -4 to +3 is only going to be between here and here. So we're actually not going to use the A and E regions at all. It was excess information that's not going to help us here. So we're going to see how much area is below the x-axis in that interval. So we have a 4 and a 15, so that's a -19. And then we're going to look at how much area is above the x-axis, which we just have region 7, which is region C, which is 7. So we get an answer of -12. And that's what they're looking for you to type in. Again, the negative is basically saying there were 12 more square units below the x-axis as there was above. It's kind of like a net difference is what's happening here. So let me show you another one of these. Another thing that sometimes I do to help me is I'll go through and I'll label all the stuff above the x-axis in one color or below in another color. So they tell us that A has an area of 5, and I'm going to do D because it's above. It has an area of 4. And then below the x-axis, I have B has an area of 6 and C has an area of 19. So that's another way you can kind of show those different areas. It wants to know the value of the integral from -8 to +5. So -8 is going to start here and +5 is going to end here. I like to do that to make sure I don't include stuff that's not being asked about. So I have 5 square units above. I have 25 below. So I'm going to subtract the 6 and the 19 because they're both located underneath. I'm going to get -20, and that is going to be my answer for my definite integral. As you can see, these go really fast. So let's start looking at ones that are not abstract regions. They're actually geometric regions where they're going to ask you the same thing, but they're going to make you work for it a little bit more. So this particular one is a definite integral from 9 to -3. I really, really think it is helpful to actually write that out. So -3 is here and 9 is here. And it wants you to find the integral from those values. So we're going to have to find area. Now, the one thing you'll notice is none of the area between those boundaries is below the x-axis. So everything's going to be positive. And what the other thing you should notice is it has 2 regions and they're both triangles. So you are going to actually do some geometry here. There's not a lot of geometry in calculus, but this is kind of where it is. We are going to do 1/2 base times height for each of those to find the area. So my first one, my smaller one, is 1/2. My base is 6 and my height is 2. So 1/2 of 6 times 2 would be 6. And then the triangle that's next to it, also 1/2 base times height. My base is still 6 and my height is 5. So I get half of 30, which is 15. Add those up. They are both positive. We get 21. So that's how we do it. If we aren't given the information, they're going to force us to use some basic geometry. So let me show you a couple more here. So we're going to go from 0 to 9. So 0 is starting right here, and 9 is ending right here. Here's where you get some options. If you want, you could cut it up into a triangle and a trapezoid. If trapezoids are not your thing, you can slice it even more, kind of like, again, a basic geometry skill, and you can do it as 2 triangles and a rectangle. So my triangles, 1/2 base times height, are 1/2 of 3 times 4. And so then 1/2 of 3 times 4 is 6. This triangle is exactly the same. It is also 6. You also could have put them together and just made a rectangle. And then the last rectangle is 3 by 4, which is 12. All of my regions, again, are above the x-axis. I started with those because those are the easiest ones when you don't have to worry about negatives. And you get 24. Now we've got a little bit that's below, so kind of taking it to slightly the next level. So now we are looking at an integral from -2 to +7. Again, I kind of like to draw those like little boundaries so I'm not confused by other stuff. So essentially what you have here is you have this piece and you have this piece. So you can color code if you'd like. And one is above and one is below, but they're both triangles. So 1/2 base times height. I'll do the yellow one first. My base is 5 and my height is 3. So I get half of 15, which is 7.5. Notice that it is located underneath, so I am going to consider it as a negative value because of the location. And then 1/2 base times height, 1/2 of 4 times 3 is 6. That one's positive. So my final answer is actually only -1.5 because we had -1.5 square units more underneath than we do above the axis. This one went from -4 to 0. So not very much here. I'm going to color code again. I think it helps. So I've got this stuff above the x-axis, and I've got this stuff below the x-axis. They are both triangles. So we're going to do 1/2 base times height for the little yellow one. 1/2 base times height. We get 3/2 or 1.5. It will be negative because of where it's located. And then I'm going to do 1/2 base times height for the next one, which is going to be 9/2 or 4.5. That one's positive. Add them together, we get a net answer of 3. That means there's 3 square units more of area above as there is below. So that takes you through some definite integrals that are done geometrically, and it also takes you through definite integrals that are done more abstractly, where they have to give you more information. They should be quick no matter what.